Hello everyone, this is Milo from Waveforms Bar, and today I am going to show you how to make this 3D model inside Grasshopper and Python of this image. Okay, let's start. What you are seeing here is basically a 3D geometrical model of a sine wave that I used to make into this wave-like form. This is also coincidentally the waveform logo. I got the idea from sine waves, which is also called sinusoidal wave, which is defined in Wikipedia as a periodic wave whose waveform is trigonometric sine function. You can understand it as you can see in this diagram, a point. If you give it a certain function, like a trigonometric sine function, it will move in this wave-like path. You can see this type of movement in like how winds and sound and light, basically in a wave-like form, and it can also be found in nature, which is very interesting, as people like famous intelligent people actually found this character in physics and made a formula. Okay, let's move forward. I use this formula, which you can see here. Y is the function of t is equal to a sine and bracket 2 pi ft plus this sine. Okay, here you can see a is the amplitude, which means how much high the point will go, and t is the basically time, and angular frequency, ordinary frequency, the number of cycles, and phase. We can apply all this inside Grasshopper and Python and apply it into our design. So let's move ahead to Grasshopper. I've already opened this inside my Rhino. I will first use the top view. It is much easier for initial design. Now, first of all, I will create a Python component. Yes, I made a mistake. I will use Python 3. Also, a disclaimer: this tutorial I'm doing is not beginner friendly. Okay, it's a small warning, as you'll need to know some basic idea about Grasshopper and about some basic knowledge about Python and coding in general, because I will talk about lots of ideas regarding inside coding in Python. So be prepared. Okay, let's start. So this is our Python component inside Grasshopper. And I know script syntax as then I will also import map, which we need for our sine value. Now we have imported our libraries. We need to correct our functions, I guess. Sorry, make our correct inputs. First I will give let's start with time, the t value, and let's go back to our formula. You can see I will I'll put the formula here so it is easier for me to check. Okay, time function. Next I'll put A for amplitude, then I'll put the C for the phase, this value, which I'm not sure what is called, so I'll just put it C for now. You can put whatever variable you want. Next I'll put the F for frequency. Next I will need a value for the x direction, which is this x-axis. Sorry, for the x-axis we'll need a 0 to certain number, let's say 100 for x value, which is basically a domain. You can call it as a domain. So I will put x underscore domain, and between the x, first let me put the domain value here. We need the domain component, sorry, construct domain range of the domain. Step will be one step at a time. Let's start from 0 to 100. So this will be our domain. Let's check our domain with the panel. 0 to 100. Okay, then next we need a count input for domain. So I put x into count. Let me put 0 to 10 for now, and we'll get back to it for the appropriate value. Okay, now let's put the time function 0 to, let's say, 5. Let's just copy this value. We'll put proper values, and we'll make it more accurate later in this tutorial. Okay, now we have the basic inputs for our formula. Let's continue with our coding. First I will need to unpack this domain. This domain is 0 to 1, so let's check the value inside Python. Print domain, let's see, 0 to 1. Okay, it looks fine. Now what I'm going to do is unpacking list into minimum and maximum values. There's something in Python which if you give it a list of two numbers, like where we have 0 and 100, we can unpack it into 0 as a separate variable and 100 as a separate variable. So like we can write this code: x minimum, x max is equal to x domain. Let's check the minimum value x min is. We already have an error which is called cannot unpack suitable for float object. What that mean is that we need to change this x minimum value into float. Basically we have the wrong data type, which is very important when we are using Python and Grasshopper, and especially converting in between. It is a really big headache. So what I need to do is called to float. so I will convert it into float value. Okay, let's check. Still unable to float value. I think I made the input of this domain list. We need list access. Okay, let's see. It is float. Okay, we have checked the x minimum value, it is 0. Let's check the max, it is 100. Okay, I think we are good for now. So we have unpacked x and x min and x max. I'm sorry, x domain. So now we have to do is what you call in this algorithmic scripting, it is called number remapping. We can use that in, we can also use that using components in Grasshopper, like remap numbers. And there are lots of tutorials in YouTube, so you can check out about remapping them in YouTube. I'm sorry, in Grasshopper, but we'll not do that today. We'll do that in Python. So let's make a comment on remapping numbers. Here I put x value equal to, and now I have to put a long formula for remapping. Basically equal like x min plus x max, x max minus x into I by x count minus 1. Now I will put a for loop in what is called list comprehension. List comprehension is just compact code, compact method in Python to make short codes. Okay, this is for I in the range for x count. Okay, I think this x count we need to change it. Let's see if it works for now. Okay, let's see, it's working fine. Let's check our remap numbers. Print x value cannot be interpreted as integer, so I'll need to put an integer. Let's see if this works. Nope. I need an integer. Okay, let's see if this works. Let's go to int. Okay, finally I figured out the mistake. I need to convert these numbers into float. So finally we have to remap numbers. You can change the number of remap numbers, and you can see from 0 to 100 the numbers have remapped with the amount of count, like 2, 3 numbers, 4, 5, 6, and so on and so forth. Okay, finally we have remap the numbers. Now we will go back to our formula and make this shape. We will make a bunch of points, and interpolate a curve along this sine wave shape. Okay, let's continue. Now let's generate the sine wave points in Python. Okay, first we put an empty list of points, and we'll make a for loop to plot those points along our remapped numbers. Okay, now we'll put this formula I was showing you all along. File will come in use a into mat dot sine 2 into mat pi into f into x plus t plus c 0 sine wave formula. Okay, points dot depend y 0. Now the points will be appended along the sine wave curve. Okay, float and non-type. Now I will have to make a logic gate because there are some non-types in the file. Okay, logic gates to check validity of our inputs. T is equal to if T is not known else 0. We have to put these logic gates or we'll get that error. Not that error, I guess. Let's see if this works. Finally, I solved another error in our debugging session. So this is like what to do when you do coding. There's lots of debugging, lots of time scratching your head and debugging, seeing what the error is. So I needed to put the right type of input. So I put integer in all these values: amplitude, this phase shift frequency, and for time I put float value. Let's just put one here for now. Let's see what we have. Let's print. Okay, now we have. I think we still need this logic gate, so we'll put it here. No harm, no done. So we have a list of points. It's looking good. Now we have to plot those points. Okay, to plot them we need to interpolate the points into curves. Okay, for that we need to add interpolate point, but we need to put a logic gate first. No, we'll just do it. Sine wave curve is equal to iris dot add inter curves points as an input. A is equal to sine curve. Let's see our output. Curve, okay. So it's working. Now we can also see. We will delete this for now, and we can see a small sine wave curve. Now let's first put some logic gates here as well. If then points is greater than 1, then else sine curve is equal to iris dot add interpolate. Yeah, sorry, what the hell I'm doing. No, this is for if the input there are there are insufficient points. Okay, our code is done. Our code is done. Now we have to make this design using our code. So let's do it. Now we'll delete all this. I guess we don't need it because our code is only a series, because you can see we have three. Actually there are 5 curves, 3 down and 2 up. We'll make 3 curves in, I'm sorry, 5 of the 5 curves inside Python. For that we'll need to make a series of 5. Let's start, let's say 2 steps, I guess 4. We'll change it later if we need to. So we have also a series for the amplitude. We can now see there are already 5 curves with various amplitudes according to our series, like C 2, 16, and so on. Now we will make another series. Copy this. This is for the phase shift. Okay, now we can see our shape, it is shaping up. Okay, now we have to change the frequency. Let's change this frequency value and let's see. So it is I guess I think we need to put more decimal points. 0, 0. Let's see. Okay. Maybe change the count or something. This is also not bad, but we are not getting the one sine wave wave function we want. Oh, sorry, we also have a time wave. I'm stupid. Okay, yeah, we almost, it is pretty similar, I guess. Let's see. Okay, yeah, okay, this is it. This is the one we want. Now let's do some coding inside Grasshopper, from Python to Grasshopper. All the curves into this curve container. We use dispatch for odd and even. It has already a pattern true and false, so we have to list odd and even, and we'll push we'll move the, I guess, the even ones in the curves that are even. Move. Yeah, I guess for now. I need to push this one. Yes, we need to push this one. Yes, okay. Now we need to do some lofting. Before that, we need to arrange this curve, the list of curves. List item. The first curve, third, okay. I'm just arranging the odd and even lines serially. Okay, 0 to 4, because we have 5 items. That's how it works in Grasshopper. Okay. Let's merge them all together, and finally we will have the list we want. 0, 1, 2, yes, so 0, 1, 1, 2. Okay, now let's do the loft, and I think if everything goes well, we will have the design. Finally we have our design. Let's hide all this. Custom preview, color swatch white. Okay, let's see. Finally we have our design. Thanks to Grasshopper and Python, so we can change the design as well. You can make other types of design as well. You can have fun making other shapes and using this sine wave formula. Can I add more? No, sorry, we can't add. It will throw an error. So this is it. This was my tutorial. I think it went far too long. This is not for beginners. Sorry, but so if you want to know more about Grasshopper and Python, I am planning to do more introductory, beginner-friendly videos, especially Python for architects and Grasshopper also architects, by the way, and designers and interior designers as well. Okay, so thank you for watching. I'm planning to do more videos on using Rhino, Grasshopper, Python, and maybe also doing some AI visualization as well in the future. Let's see. Okay, thank you for now.